No, there's absolutely nothing wrong with my audio. Ridiculous. Hey, Kotaro. Well, it should be done, but it hangs. So I think I'm close to finishing it. I'm just happy to see you again. And then I go visit my dad because it is Sunday. How do we figure out why it hangs? It hangs in merge. Merge works, so we are passing iterators in a bad state, I guess. Maybe we should start with printing it. This is dereferenceable. Maybe we can do it the first time. See, even the first time it doesn't finish. Whoa. Well, you can see it. Yeah, very short. La 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 la. Yeah, this is all. I already realized what is the problem. However, I didn't null terminate anything. So before we start even with the merge sorts. Yeah, this tail recursion is bullshit. I should just make a loop. So instead of return, I'm gonna do a break. And then we do an infinite loop. And then I have to set the previous values of all the nodes to null. I am thinking about if I can set. Yeah, this just uses the next pointer of the base node. So I can just literally set, including the base node, I can just set everything to null. Feels kind of like a waste. I think the first iteration, which it just sorts between quotes 2 elements at a time, I can use separate that out, I think, in a different loop, and then use that loop to set all the previous nodes to null, instead of doing that in advance and then use it to make it work with the existing code. That's just, yeah, nah. But for now, in order to test really the simplest code, basically test the algorithm itself, I guess. I'm just going to start with iterator begin is the get node of P. Well, actually no, that's the end. Let's I did corrupt something already? I didn't even corrupt anything. Oh yeah, not at all. Not at all. My list is completely intact. That is, I just get the end pointer, but well, you can decrement it. Uh-huh. You mean the merge sort? That yesterday was also merge sort, right? Already. Let me think. I can just forward iterate, I think, to just use the next pointers, and then clear the previous pointers on the go. P is end the beginning, so we begin with forward iterating. And if that makes it the end pointer again, then well, let's assert even P is end, that works. Oh, wait a minute, P is end is uses previous, so I cannot reset the current thing then. So we have to first increment it, and then reset the node. But That doesn't work either. Shit. I'm gonna walk backwards. This being end, it feels weird to do plus plus anyway. I mean, if you have the, in my case, if you have the end iterator and you do plus plus, you get at the beginning. But yeah, end is both before begin and after end, because it's a circular list. But let's treat it like a real end. So we do minus minus p. Now it points to the last element. And then I'm going to reset the previous iterator. So we do something like get node of p. Previous is null pointer. But then we can't do minus minus p anymore, so we have to do that in advance. So I'm going to do iterator previous is standard previous of p. And then we can assign p is the previous node. So now we set, say if p is begin, then we set it to null. And then we set p to previous, which is then the previous of begin, which means it is end again. It's just how it works. I can't help it. So yeah, just end again. So while p is not end, this should work. Can even put it at the top. Still not working. No, merge is never called. Okay, what happens? So p is never end in this case. Well, that's interesting. I guess the previous pointer of end did get reset before we tested. Let's check the sanity of the list that we get initially. How many elements does it have? Can just go up, print it. What the fuck, debugger? Size is 10. Okay. The P is end, so this is the first element. So this prints the second, this prints the third, this prints the sixth, this prints the ninth element. This prints the 10th element. And then this should be end again. Yep. So far so good. And then of course we have previous pointers. So we can go the other way. Previous is one more than a pointer to the last element. That's also correct. So yeah, have to untaint it, I guess. Untaint. Not sure it actually works. It does. So that is then the last node. And then we do previous. That is the second last. I don't know, we just need a bunch of previouses. What do you think? Is that enough? Apparently not. Or maybe this was already enough. Nope. One more then. Yep. So that totally works. Well, the list is saying. And now what are you going to do? Frame minus P. Well, my friend, I'm gonna step. This is doing minus on the base class, which is setting pointer to pointer previous and untaints it. Which means that pointer now equals that value. Yep. Which is therefore correct. Okay, now we are here. So now P is obviously not end anymore because, well, it's just not. So we do next. It did hang. Why the hell did it hang? Oh! Oh my god! Oh! Kotaro, why didn't you tell me, man? It is kind of funny. Yeah, I had this wall at the end, and then I decided to move it up, but forgot to remove the semicolon. Burning CPU there, and a lot of time in debugging. So, like this anyway. And it still hangs. How the... Seriously. We did read... Speechless. Completely speechless. Oh no, that was... Sorry, that was the bug that we did run into. And then I changed something, and then it did hang even in merge sort, which was this bug, but still hang in merge. Yeah, but we hang in merge now, while I did reset all the previous pointers. So I have to look at it again. I already checked that the list is sane in the beginning. That is bullshit. Isn't it? No, it's not, actually. This previous has a pointer. Maybe I should print a pointer. The contents of the pointer. That's what we need. Yes. So P is pointing to next, and this is this object, which has points back to that object. And now we're going to reset one of the previous things, meaning so P points to a node. This is the last node, because that node points to an end. And we have set previous to null. And then P is previous. So it's not end. Previous. Now we have that and that. Next. And now that is null. It looks like it is doing the right thing. Okay, now it should be end. So this is as pointer with with an odd previous pointer. So this is end, and then we indeed leave it. And I use P. How the hell is previous still set here? I don't get that. Oh, P is end. We did not, yeah, of course, this is end. This is odd. So I did not reset the previous pointer of the base node. That should not be a problem. Yeah, so C is set to this one. Yes. And that one has a 0 previous pointer, but still has a next pointer, so we can go from even starting at P, can still traverse the whole list following next. This is probably something simple. Should go a little bit faster, I guess. D, print D, pointer, content, In the end, I can just print the content of a lot of nexts. I think. That's end. That's the last one. This. So the next one is of course end. Well, okay, looks sane. There's not a single link, single thing left. How is that checked? Checks if the PTR is equal. Yep. Step. X is now end. Yeah, P was end, so X is end. And then we set the next pointer to whatever merge returns. And now both C and D must be a single element as per being treated as a singly linked list using the previous pointers, which means that they must be dereferenceable, as in C is 96 and D is 40, but the iterator itself has a previous pointer of null, so it is just a single element, and D as well. I have no idea what that would not work. So enter merge. Store the iterators. Check which one is largest. Oh, what? Okay, this is slightly problematic. Well, maybe it isn't. So last is now... Hey. Yeah, last is what it was. So we can do last dot pointer. Dereference that. I could cast this to a value type, and then we will see that it is one of these values, but whatever. But more importantly, last node should be null pointer. No, it's not. Well, actually, this is failing then, is it? No, previous is null. Previous is null, sorry. So this is the last element, yes. Yes. This is the last element in the list. Well, yes. Oh, I didn't skip it? Wait a minute. No, I did skip it. We did do this. But don't think this iterator is usable anymore. That is the problem. It's a null pointer. Or maybe I'm not using it. I should be using just last probably. The other one is usable. Yes. So break. Get node lost. Do the lost node. Still that, and now we set the previous pointer to point to the node of ethers 1 minus largest. Yeah, well, that looks good. Turn largest iterator. So now this iterator is having a pointer. I'm gonna cast this to value type. And then dereference it. So that is 96. And the previous one exists and is 40. And there is nothing before that. Oh, that totally looks correct. I mean, it has been merged. And we return something that points to 96. Yeah. Oh, wait a minute. I forgot something. Yep. Yep, we are not updating the pointer to Y. This must be updated as well. So merge is doing this whole list and returns a pointer to D. And then we set P to point to that returned value. And we set the next pointer of X to point to that value. But this update is not done. That's the one that's missing. So we want D next. So that is not really D, it's what is returned. So I could use X for that as well, or X next. Or just P, I guess. P next is Y, and Y is Y, that's a good question. So yeah, Y is what the last one was pointing to. So that is D next. Well, doesn't look sorted, but it doesn't hang anymore. Yeah. Let's just start printing debug output again. Yeah. I don't know. I don't know. Yeah, mine is also not recursive. I just have a loop, a normal loop. Yeah, I just want to dump the thing on one line. That's so irritating that print using didn't work. So we separate it in a single function. I guess I can still use this. Have it dumped the list to an O stream. It's ridiculous that I can't use a print using. I need to fix it. I want to have a print using that I can pass a dereferenceable object to, like an iterator, which then just calls a function that takes that iterator. It's actually quite simple. I should simply test if the function takes the same type as what I'm trying to print. Then it should not dereference it, it should just call it. But it doesn't. Yeah. So basically broken. I don't feel like fixing that though at this point. Okay, fuck this. Result code duplication. Well, maybe not. Let's do it like this. Dump single linked list on standard ostream reference OS. Without the prefix, then I suppose. And which then means that the prefix is already printed, and we just write OS to OS as well as here. And here. And then we can do this. Or not. That would be the rest. But I want it on the same line, so I don't want to have a new line here. I can suppress the new line here and then dump it, but I might as well use this continued, which would work a lot better in the multi-threaded environment. And then finish it here by printing nothing. Now the problem is, this is not working because well, I need to pass the O stream of I need to pass a debug O stream, or a debug O stream rather. So I still need to do a print using then. Maybe just wrap my iterator into another type. It is possible, but so dirty. Let's do the dirty thing. File, new tab, YouTube. Oh, you guys were looking at a small switch profile. YouTube. No, sorry. Never mind. And I don't know. This is my new tab. I need to go to libcwd. That's probably just in projects. Totally is libcwd. Include. The out. Okay. I'll see you around. You said what? Sorry, before you go, if you're still there, you say it's it is not working because of this sound in background. Can you explain that? You mean you just stop this stream because I'm distracting you, or is there another sound, or is my audio bad, or do I have something in the background here? Seems quiet at the moment. Well, he already left, I guess. I can use some documentation here. Route to current OSS. This is probably what I want. Yep, I think I just need to replace the out with all of this. And then I can insert something here. So it doesn't get any dirtier than that. Told you it was dirty. Still need to find where the out is defined though. I think the out is defined in CWTS, the other one. Let's see where that is. List dot 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 dot. CWDS. Dot H. Just the empty ones. No. The out must be defined here somewhere. But where? Okay, so we have to pause this. to this one only has, oh, this is for debug output. I think I'm copying the wrong thing. Look, ding ding. That is the right thing, and the out is defined in terms of libc w d out, which is probably built up way better. Nobody knows where it is defined though. Not here. Yeah, see, that's what I was really thinking. This can't be that dirty. Here we have the stream. So if it just splits up in 3 lines, really. Much better, much better. Okay, so forget about this. We're doing those 3 lines. Where this is the DC namespace to which this is passed, and this is the debug object to which this is passed, and this is the control to which this is passed. Don't need continue now, and then we can write the data. Here, where now the data is the prefix. The prefix is written, and then we can pass that to our function. On terminated invoking the out entering. Oh yeah, right. But yeah, then we have to do the same thing here. Ugh. Still not inlined. It's probably not a bad idea to just make a separate struct as a wrapper for the iterator, and then use print using. Use print using. I think I'm going to do that. So it's a bad thing of the print using, but okay, just make a iterator wrapper. Which is now no longer dereferenceable, so then we can just pass foo here. instead of the iterator. Then we do it. Let's see if this compiles. No, now we can do some of the same thing. It's I should have thought of this earlier, to use print using like this. But I think I should fix print using so you don't have to wrap it, because it should see that the type of the L0 is equal to the argument of this function that is being passed. And then you can just accept an iterator. So we're calling merge, and then we print the first list, followed by a comma, followed by the second list. And then we get the debug output of all of that. And maybe I want to dump the result as well, just to be sure. To print okay, so that's not good, because it must be descending, and 22 is larger than 10. For the rest it looks good. Now let's see where it goes wrong then. So entering two list with just a single element, and then we return a list that has two elements, where the largest one is first. That is correct. This one is also sorted correctly. These two are sorted correctly. I see it coming. The problem is that we don't have a power of two number of lists. I'm not taking into account that at some point you don't have a list left. Yeah, that must be it. So this one is good, this one is good. This one is good. It's not good. Oh, but that's because 1022 is passed. But okay, then that might be caused by that this was already the end, really. I mean, that should have been 2210. But yeah, it's definitely not the case right here. I mean, 22 is part of this list, so if it's then suddenly it pops up here, I think this is the size. Yeah, this is the base node, which stores the size. So you get to see the size as the integer, and then 22 is the first of that list. The moment that this is called, we are passing nonsense here. There is no list. We are already done. We should already have stopped here, I think. Or start over, rather. Oh, that's a good point. Yeah. Oh, okay. Algorithm still not correct. Yeah, I don't have to look at this. I think I can figure it out just from the code. So the end condition is wrong to begin with. I mean, that is the end condition of the list being completely sorted. But we have an intermediate end condition in which we have to start at the beginning again. Intermediate being, well, for example, if you just take this example, begin with that list, and we sort 6 and 5, and then 3 and 1, and then 8 and 7, and then 2 and 4. And now we're at an intermediate end, because next we want to start over again at the beginning. And then sort, merge these two lists, which I'm not doing. So what it is doing is it's not detecting that we're done here, because we're not done, and just continues merging B and 6. Yeah, that's what happens. Where the B is then the 10 and the 6 is then the largest thing that we had so far. So that's what's happening. So what I really need is to detect that we just merged a list that where the top thing is now pointing to the base node. So this remark is correct. Until P next points to B, which means that Y is B. But it is not true that in that case X is B too. So note that if the list is fully sorted, then case is B2, and at the start of the next step, X is D. And I think there is still a remaining problem where there is simply only one list left. So if, say, Y, there is a C left, but not a D. In that case, we can't merge C with D. I guess that in that case also just a board. Should also reset to a P to the beginning. Even if X was a list, then we just reset P to point to the beginning, and then we merge X with the last list C. So it's not enough to have C point to B. Sorry, to have X, X, the thing that P points to, point to B. It's also sufficient if D equals to B. So if C or D equals to B, then we have to do that. So it is actually until P next points to B, or P next points to B. So that is at the beginning of a new step, either C or D is B. Yeah, because if we start over, then P points to X, so this becomes X, and this is C, and this is the next one is D. So we got really this situation, and if this is B or this is B, then we want to start over. Except when we are totally finished, in which case X is D. But there's also B. We must be able to check with B. So I guess if X is B, or let's see. I mean, we check this, and then we want to either begin at the beginning or terminate completely. And we already have B apparently. So in that case, X and Y are B. Sorry, I want to begin like here. So X is the finished list. So then C equals B, yeah, and D equals X. Yeah, that is the terminating reason. This is not correct then. This is not correct. Oh, at the start. No, wait a minute. Let's see. To start, this would be B. We have one list, and then D is also B. Yeah, at the end, in the end condition is simply that X and D are both B. Which probably only happens when they are equal. Let's put it in English. I typed IS before for the where, so at the start of the next step, both X and D are B. Okay, main problem is we don't have B, but we do because the thing enters with B equals B. And I'm updating P. So we have to compare C, D and X with it. And at the beginning of the new step, that would be here, I think. So at this moment, X is defined, Y is defined, P is defined, and C and D are defined. And this is the wrong ending condition. Yep, I want my B. Let's just use an iterator because most of those things are iterators. So iterator B is P. Might as well put that here after the assert that it is end. Nah. Should declare stuff as late as possible. I'll add a comment then. So now B points to the base node, and the terminating reason is if C equals B or D equals B. And that is not a single list. But yeah, if C equals B, then we did do a standard next on the end pointer, but it's not really a problem though. not with the utils. Get a comment for that. If well, we could do 2 breaks, I guess. Okay, let's turn this around. I rename this to B. So now I want to test if x equals d. Because then we are completely done. But neither x nor d is defined there. So instead I will make a boolean. Make a boolean done. And see, I want to have a single one, so I'm just going to combine these things. Why do the top all at it's everything changes all the time here. Okay, I'll put them there, dude. And so theoretically I could delay this thing, but I'm gonna do it anyway here. So we want to break and we want to set done to true before breaking if x equals d. And we have d, but we don't have x yet. However, d is an iterator and x is going to be at the beginning of the step p, so we can just compare with p. Yep, think so. Yeah. This, my friends, is sorted. But we are curious if what the initial lists were. Why is that not printed? Yeah, I believe the thing in the middle, so let's turn that off again. Merge. Now you see why I use a macro for D out, because this kind of shit is super ugly. And I could just use a debug channel, I guess. But like I said, I'm going to delete it eventually. If I make a special merge channel, then it's going to be always off. It is just a waste of whatever. That wouldn't even slow it really down, but still, it would be a Boolean check. Plus a lot of code to read in. So yeah, not okay. Only in debug mode. So the macros become completely empty when no assembly result at all if the debug mode is turned off. And it's debug out is not noticeable. I mean, if the channel is turned off, it's definitely not noticeable. So yeah, I could make a separate debug channel, but I don't know. I already added it now. Debug merge sort around all the output. It looks so ugly that I would almost undo it and then add a new debug channel. Yeah, I guess that is okay. At some point you had, a few double things. Well, we have that, and those are double as well, so we see them both appear. Looks cool to me. You know what? Let's print the entering anyway. Really, I would like to special case the initial merge of just two elements. I feel that it's warranted, if only by the fact that we have to visit every node while resetting the previous pointer. So I think I want to do that separately. And then we end up with a list that already exists of lists of two elements, where then only half of them have the previous pointer reset. That would definitely be faster and less calls to merge. So then these calls would be done. I mean, I think merge itself is not in line, right? So the calls to merge would be removed. I think the code would speed up. And then we would still have these calls. So it all just hangs on how fast merge is, right? Merge itself. Yeah, I'm happy with it. So I'm gonna leave because it's time to visit my old father. As long as he lives, maybe he's so fit, he's probably going to live another 10 years, but I don't mind. He's a nice guy. We play cards usually. I mean, he's having Alzheimer, But yeah, well, that means that we can only play one card game, the one that he knows, and even then he still makes mistakes sometimes. You know, he forgets. How do you call a card game in English? You can ask the AI. This is not something you cannot look up. Okay, how do you call the Dutch card game Piston in English? Holy shit, they turned off projects? Oh no, huh? What is the date today? I pay till 6. Oh, I have no longer a professional plan. It still sells professional plan, but... Interesting. Well, it's a till 6, I guess, so... It says professional plan, but as soon as I reload, it's gonna say something else, I think. The Dutch card game Piston is typically called cheat or I doubt it in English. The UK is often known as cheat or something's bullshit. In the US it's commonly called I doubt it or BS. Some people might refer to it as bluff. Nonsense, isn't it? Well, I didn't know this. We have the rule. Oh, use the rule that if you can play a card, you must play the card. Can you summarize all yeah, I don't know, playing rules of this game, just to be sure we're talking about the same card game. This is reversed. Is that really the case in the US? In the Netherlands, and I think AI is just confused. The jack means that you can change the color of the card or the suit. And the 8 means that the next player must skip. 2 means you have to take 2 cards, yeah, draw 2 cards. We don't use the ace because you play with 2 people. If we do, I use a 10, by the way, to change the direction. Instead of the ace. So it's definitely not bluff. Yep. Yep. Okay, the game you design more like, it's apparently in English it's called Crazy Eights or Switch or Last Card. Yeah, so that's what we do. Because you can't learn anything new, unfortunately. And even then, sometimes I was telling he makes mistakes. It's just forgets that how the jack works, for example. Or he keeps forgetting that if you can match the suit as well as the number, then he keeps asking me if you're allowed to play either, or if you have to play, always have to play the suit. If you also can change the suit by playing a matching number. And the funny thing of that is that I explain it and then he knows it. But on the next Sunday, it's the same. It just doesn't get stuck. Right. Thanks for watching. I have to go.